we have already studied that by increasing the size of a prefix, and we know what is prefix is. Prefix is the elements that are already in the ordered form. So by increasing the size of a prefix, we can easily sort the elements in any set. So by using this strategy, by increasing the size of a prefix, we can come up with an algorithm that can sort a permutation by repeatedly moving its ith element to the ith position. And we have already know what is the ith element and ith position we have studied in the previous modules. So this is the algorithm we come up by using the simple technique, and we can increase the size of a prefix, and we call this algorithm as simple reversal sort algorithm pi. So pi is the elements which are present in different orders. So in the first step, for loop will start and we will assign the value of 1 to n minus 1 to I. And in the second step, we will assign the value of j, position of element I here, in pi. So it means that the element could be any number in the pi. And we can assume that this is the pi j is equal to I. It means that j will be equal to I in the second step. But if we assume that if j is not equal to I, then we will assign the value of pi into rho, means the values of I and j to pi. So we will get the pi in the ordered form. And if pi is the identity permutation, it means if we will achieve the identity permutation, we will get the answer. So simple reversal sort is a type of greedy algorithm that chooses the best reversal at every step. So the notion best could be the misleading and is short-sighted. So by increasing the size of a prefix, we cannot say with surety that the number of reversals will be reduced. So the small number of reversals by using this algorithm cannot be guaranteed. So we can see that here is the simple reversal sort. We have seen previously that this simple reversal sort algorithm cannot be used, and we cannot guarantee that this algorithm will reduce the number of reversals. So if we use this simple reversal sort algorithm and use this ordered 6, 1, 2, 3, 4, 5, and we want to arrange them in the ordered form by using this algorithm, it will take 5 steps. So in the first step, 6 and 1, they will be reversed, and 1 will come at the position of 6 and 6 will come at the position of 1. So we get this one, 1 came before 6, and in the second step 6 will be replaced by the number 2. So we can see that in the second step 2 will come after the 1. So in the third step 3 will be replaced by 6 and 6 will come in the place of 3. So we can see here, so 3 will come here and 1, 2, 3 will be in the order. So this will continue until all the elements will be in the ascending order. So we can see here it will take 1, 2, 3, 4 and 5 steps to arrange these numbers. And we can arrange these numbers in 5 steps by using the simple reversal sort algorithm. But there is a drawback in this algorithm, as we have seen previously, that we cannot guarantee the minimum numbers of steps. So here we can see that the same problem can be solved and the same permutation can be sorted in just 2 steps instead of 5 steps. Here we can see we can simply reverse the order of this one. So if we reverse the order of whole of these number, 5 will come here, 4 will come after 5, then 3, 2, 1 and 6. So we can see here 5 place in the first, then 4, then 3, then 2, 1 and in the last 6. And in the second step, if we again reverse these 5 alphabets, we will come up with the numbers in the ascending order. So what we will do in the second step, we will permute this one 1, 2, 3, 4 and 5. And we can see here, so 1 will come in the first position, then 2 will come, then 3, 4 and lastly 5, and 6 is already in the last position. So in only 1 and 2 steps, we will get the same answer as we get previously by using the 5 steps. So this simple reversal sort algorithm has some drawbacks. So this simple reverse sort algorithm is not a correct algorithm. Despite its common sense appeal, this simple reversal sort algorithm has many drawbacks. And we can see that it can take n-1 steps to sort the permutation, n1 to 2, and it will go up to n-1. And we know that it will use the d pi. D pi is the reversal distance and that is a 2. So the drawback of this algorithm is that it takes a large number of steps to arrange the order of the elements.